Boston Dynamics has really been focused on research and development. So I think their goals of what they really want to accomplish are very different at a high level than what we want to do. I think they really want to push the technologies to places that are almost as good or better than what humans can do. That's kind of like the inverse of what we want to do. It's like we're at the complete opposite end. We want to do nothing better than what like a non-expert human can do. So we look at like the distribution of what every human can do in terms of like what they do every single day. We want to just do the blocking, tackling work that a most normal human can in the world.
All right, guys, what's up? I've got Brett here with me. Brett, I thought a great place to start this conversation was around ambition. You spent a good portion of your career working in the technology and software industry. There's a lot of people who are building all kinds of cool software, but it just might not really be that inspiring to the average person who's looking at it from the outside. Now, all of a sudden, you start working on this like advanced hardware and people start saying, wow, look at what this guy's doing. He's got all sorts of vehicles. He's got robotics. Like this guy is really going for it. What changed in your career and like why kind of switch from what many people from the outside would say like cool, but maybe not the most ambitious thing to now going after what many people would consider the tip of the spear of innovation and ambition?
Yeah, well, first, thanks for having me on today. Yeah, I can maybe give you a quick insight into just my career in general and maybe how I got here. Maybe it's a helpful roadmap for other folks. So I've done about 20 years now in building technology companies, a little over a decade, maybe like 15 years or so in software and internet. The last like 6 or so years have been in areas of advanced hardware and AI. I think, and listen, there's a lot to unpack with that question. I think, fundamentally, I think software basically gave me the personal balance sheet to chase some of these harder, more moonshot or deep tech ideas that I feel like as an entrepreneur, it's like we're on this journey to kind of solve these harder problems to make the world better. That, frankly, it was just a really privilege for me to be able to try to work on some of these harder problems the last like 5 or 6 years. Yeah, so my journey's basically been this, like a marathon. So, probably have built now over a dozen companies. And yeah, for the last like 6 or 7 years, I've been trying to swing pretty hard at some of these harder problems in areas of the hardware and AI.
And why is that the focus? You mentioned the personal balance sheet. Maybe you could explain a little bit in terms of, was there a certain number you had in your mind? Was there a threshold? Was it something like, hey, I could live for 10 years and not have to pay bills or worry about that stuff? Like, what was the thing that kind of unlocked mentally where you felt safe enough, I guess, to really go for the most ambitious thing you could think of?
I think fundamentally, like, there's not a lot of investors funding the stuff I've been working on. So you look at the early days of like SpaceX and Tesla and Rivian, like they're not, the venture investors are not in there. And so, so you really don't have a lot of private equity or hedge funds or family offices or even sovereigns coming in very early. So it takes a really special, it takes a really special type of financing to get into this space. And for me, after selling Battery in 2017, I basically fully funded Archer for the first year or so, first 2 years. And same here, figure for the last, first year or so, I just personally funded the business. So I think, yeah, I think it's a really tough space, and I think it takes a certain type of, conviction at the personal level to be able to fund these type of things that I think traditional ventures generally shied away from the last 10 or 15 years.
And when you start thinking about, let's go with Archer first, right? Like, why pick that advanced hardware? Right. And maybe you can just describe a little bit about the business, but there's so many different things
Yeah.
you could work on. Obviously things, space and various other kind of ideas that people have really clinged on to. But you went after something that maybe people thought, was more sci-fi and not like actually going to happen. And you've been able to not only build the business, but eventually take it public as well.
Yeah. So I started Archer in 2018. It was a really rigorous process I went through to figure out like what I wanted to work on and what I wanted to spend my time at. Ultimately went through, it ultimately came down to the fact that I really wanted to help solve traffic problems, which nobody's really worked on for like 100 years. We haven't had any really advanced, technologies really help solve traffic. And, I think about half the world today lives in cities, and I sit in traffic all day long. And it's just terrible. I think second, we're having this secular tailwind where basically all forms of transportation besides rockets will move to electric this century. And so when on the early days of Archer, there was this idea of, okay, if we can start moving a lot of this traffic that's on the ground into the 3D airspace, there's, there's like several orders of magnitude more traffic you can put in the air. We theoretically can make it a lot safer. We can make it a lot, quicker for folks to get around. We can make it affordable. And I latched onto this idea that, this really hasn't been solved. It could be truly groundbreaking if I could go out and solve it. And it's, last 5 years, it's just been this incredible journey. I basically, started out just by I basically went back to school and taught myself how to build these aircraft and basically built them, this first several generations by myself with a small team. And it was just it's been a great experience overall. And I think this business can, over time, I think a lot like urban air mobility or electric aircraft can be a really important part of the transportation solution.
So let's dig deeper into this because with Archer specifically, there's vertical landing and takeoff. There's an electric vehicle. There's then what I'm just going to call like air traffic control inside of urban areas, right? There's a bunch of these complexities that you kind of put all together. And for the average person, they're like, that sounds like a nightmare trying to solve all of that. I get the sense that you thought that's why it was worth going after, was if you could solve all these problems and put it together in a single solution, there was a lot of value to unlock there. When you started out, how much of the technology had already been kind of created maybe in other areas and you were more so aggregating and putting them together in a unique way versus you all had to make, very material scientific breakthroughs and be able to do some of the stuff for the first time?
Yeah, I think there's when I started Archer, there was a lot of the fundamental breakthroughs needed to make it happen, or like the ingredients were really solved. I think we were looking at, okay, where do battery motor energy and power density look like today? Aircraft controls for very highly overactuated aircraft look. What does the airspace look like in terms of management? What does the real estate look like to solve this? What does the certification look like to certify these aircraft? And really what we were doing at Archer in the early days, and it's similar to here what we're doing now at Figure, is basically what I call applied research, where there's been something proven and demonstrated or breakthrough, where we're basically taking that and we're advancing it in a lot of areas, and we're basically commercializing the technology. And back in 2018 when I started Archer, there were electric aircraft flying around. It wasn't like a crazy thing to think of like electric aircraft could really work. And so basically building on top of that, it was pretty clear that over time we could basically stair step our way into market. We could certify like existing Part 23 like airplane in the US with the FAA. We could use existing helipads to take off and land from, so we didn't have to build like say new real estate with like tens or hundreds of millions of dollars of investment. We could use a lot of the traditional advancements that came from like automotive EV in terms of battery and motor technology. From my perspective, it looked like relatively tractable. Like there's like this really plan, and for the first year, I was basically obsessed with building out this basically Excel spreadsheet I built from scratch it was basically electric range equation. It was like this 100 lines of like all this math that basically proved that this could work. And I felt like I was running around like a madman to like all these investors saying like, look at this math. Like this is like it's fully works. It's here. And like nobody wanted to hear it for the first like 3 years or so. Like nobody wanted to dive deep into like the numbers and really understand it. Everybody had this like knee jerk reaction, like this is just too hard, or helicopters are unsafe, or this is just not going to work for whatever reason. Like, batteries barely work in cars. They're not going to work in aircraft. And so you had some of these kind of like really large blind spots in a lot of the investment community that almost laid this like arbitrage scenario for me to kind of go out and like basically commercialize this technology and make it happen. And we're still like in the pretty early innings. We have demonstrated now building out like 6th generation aircraft. We have basically the aircraft that I spent a lot of time on. Midnight just came out end of last year, which is a piloted 4-passenger aircraft. We're actively certifying that right now with the FAA. And there's a chance we could be first to market here in the US, which is really exciting.
And when you start thinking about the technology, you obviously have to interface with what I'll call like the real world, right? So this is the air traffic control, the cities, those helicopter pads, et cetera. How much of the time did you spend early on of like just make the aircraft work and then we'll figure out the rest versus it was more kind of system design, right? You really had to think about all of the different components that go into this because that would actually be reflected in certain technical decisions you guys were making.
Yeah, it certainly needs to be like the latter. We really need to think about like axiomatically designing for like the end state. That's like really important in hardware. If you don't really understand exactly how the product needs to look at the state it needs to enter commercialization, it means that you're just guessing on what the product looks like today. And like almost 100% or 99% sure you're going to mess that up, or you're just design it a little bit differently. You're going to use a little bit different battery cells that are maybe easier to procure. Put on the aircraft, you're going to use easier types of motors or whatever you're going to do. And the aircraft's going to basically be suboptimal as you enter market. There's going to be something wrong with it that allows you to needing to redesign the aircraft. And in hardware, when you have a redesign, it takes years to fix that. So you really have to look at the end state and say, what does that look like? How does the aircraft look? What does the air traffic control look like? What does the real estate look like? What are the certification requirements? Where are batteries at, at that point? Not like, 10 years from now, but like at the point where you enter market, like, what do batteries look like? Things like that. So, and then you have to basically work backwards. And then as a startup, like clearly you can't go out and produce, like a full scale 6,000 pound aircraft like day one. So the early aircraft that I was building were 12 feet wingspan, 100 pounds. And they were subscale demonstrators that we were using to kind of just basically validate that this could work and to prove to ourselves we could build electric aircraft. And then incrementally, basically, I was working on basically bigger and closer to kind of end state market aircraft. And that was purely a function of how much capital and time it takes to build large scale aircraft at this scale. If we could have built the full scale aircraft day one, like I would have certainly done it. But those aircraft cost, tens of millions of dollars. We have a team now of over 400 people, close to 500. So that was just intractable for the first few years of the business.
Talk about financing of the business. Obviously, you were financing a lot of it early on. At what point did investors become interested, or were you begging and borrowing and basically stealing as much as you possibly could to get them interested? Were they venture
Yeah.
capitalists? Were they more kind of private investors? What was kind of your experience there in trying to get something that's considered advanced hardware funded?
Yeah, when like my early days of veterinary, like I had a really hard time raising capital. Like I feel like in 2012 I went into a couple like investment meetings. I think I was meeting with Bain Ventures or a few groups. And I was wearing a full suit, and somebody told me like, "Hey man, you gotta stop wearing a suit to all these tech meetings." And I just had a really hard time. Like I just like nobody really wanted to fund the business for quite a long time. Even at Vettery, we raised a little over $10 million. So we just basically didn't spend a lot. We didn't raise a lot of capital relative to some of the other groups in the space. And so when I exited Vettery, I really didn't have an interest in, going straight into VC again. I really wanted to, in some way, control my destiny, be my own boss, and, kind of risk the capital that I had personally, which I think as an entrepreneur, like, is really important. Is the entrepreneur willing to use their own money to prove out their right, and or are you going to do it on some package use like other people's money to do that? And I'm very squarely in the former. I feel like it's really important to pony up and basically make a big bet on yourself. So yeah, the first year or two, I just basically immediately put a bunch of money in an account and just went heads down building products. So one of the big inflection points in the business early on is I was at an electric aircraft, just like an engineering design course in Atlanta. And I think it was like, late 2018, early 2019. And I met somebody there, a PhD student in aerodynamics. And the student really wanted to work on electric aircraft. And that student happened to go to University of Florida, where I went to school, and invited me down to basically meet the head of aerospace and mechanical engineering, and ended up basically building Archer out the next 2 or 3 years at University of Florida. I basically built a full lab there. I had a team of 12 PhDs, and I basically just spent like the first 2 years down there. Like I had like, my older daughter at the time was like, under one. My wife, we were living in this Airbnb in the middle of Gainesville, Florida, coming from Manhattan. And my wife's like, what are we doing down here? And I was like, we just need to learn how to make this happen. We're going to, spending like all my money making this work. I need to be basically a product expert in the whole space. And it was just a great experience. From there, the earliest investor I had was Mark Laurie from Jet. So I met Mark 4 or 5 years ago in New York. And at the time he was at Walmart, kind of post Jet sale. And Mark was like the first investor to bet on me to really make this work. So Mark put a, pretty relatively sized check in the business relatively early. So, yeah, he was basically first outside capital in. From there, we raised, I think, about a 50 to $60 million Series A in 2020, and then basically a little under $1 billion the year after.
And so when you start getting into those bigger fundraising rounds, what changed? Like you went from wearing suits and not being able to raise capital to now all of a sudden you're raising big dollars, right? And kind of you're the person everyone wants to come to. You're the person everyone wants to bet on. Was it a confidence thing? Was it just traction kind of changes everything? Was there something that you learned? Did you have a mentor that told you, hey, don't wear the suit, go do something else in the meetings? What happened?
Yeah. Yeah. Um, I think it wasn't really one thing. I think it was a confluence of multiple things that really helped. I think one is I had a track record of building businesses, and I think I really felt sufficient in being able to build businesses out. Like at the time, a few years into Archer, I basically built maybe a dozen companies. I really knew how to scale a team, raise capital, build great product, ship it in the market, grow it, just an overall good business. And so one is I had I think I had a decent track record at the time. Two is we were in a really large market. So I mean, if urban air mobility, electric aircraft can work, I think there's a pretty substantial ability to move a decent amount of traffic off the ground into the air. So think about every trip you do to the airport that might take an hour and a half. We could fly that in 10, 15 minutes. And it should be over time really safe and affordable. And so I think it was a huge market. I think I had a decent background for this. I was, putting a decent amount of almost all my net worth into the business. So I had a lot of overall conviction. We had just a great team, and we were making great product. I think like the one thing I feel like over time I've gotten better at as a CEO is, I basically am very product engineering focused. And we spent a lot of time at Archer, or I spent a lot of time when I was at Archer, focusing on just designing the best aircraft possible that could basically ultimately build the best business over time. And if you look at the Archer aircraft today, it's just, in terms of payload, speeds, range, utilization, it's probably one of the best designed and engineered aircraft in the whole market. And I think that became pretty clear in 2020, 2021, that the team was probably the best team ever built for electric aircraft. And then ultimately we had a product that could be certified with the FAA and got it to market and could do the real missions. And I think if you look at the space, a lot of people got that wrong. And I think they still are getting that wrong. If you look at the basic physics of what you need, and it's the same for any business, you're in marketplaces or SaaS, you need some characteristics that would ultimately make it a good or bad business. And, in hardware, it's what are the physics, and ultimately what can the product do in the market and commercialization perspective? I would say maybe half of all the electric aircraft businesses in the market have aircraft that are just not sufficient, on the back of a napkin. And I think Archer really emerged as this very sober, realistic, and fast-paced startup that was highly capitalized, that could basically be poised to maybe be one of the groups that can help really make this industry work. And if it works, it's $1 trillion market. It could be great. And I think that really enabled us to raise a pretty substantial amount of capital that enabled us to get to where we are today. And there's just listen, there's still a long road left. Sorry. Sorry, my lights just shut off. There's still a long road left. We have to, certify the market, certify the business. We have to manufacture at low volumes and higher volumes. We have to get into market, manage a fleet of aircraft, and move people around. That story's yet to be told. And so the team's working extremely hard on trying to get there now.
Public markets versus private markets. Obviously, everything you had done before, I think, was in the private market. Now, all of a sudden, public market, pros and cons, and what ultimately drove you there? Was it the need for capital? Was it just it's the right time? What happened?
Yeah. So, we went public through a SPAC in 2021. There's a lot of companies that did that. And, the trade that I made at the time was we could have either stayed private and not gone the SPAC route. And this was early, right? We were watching all the electric vehicles and LiDAR companies go public. And I was just somewhat shocked on how much capital they were raising. At the time in early, 2019, 2020, if you were a hardware company in the deep hardware space, there was really no venture market for you kind of after the seed round. And I did the seed round. Like, so like after that, it wasn't like the top VCs were coming in and doing the Series A at Rivian or Tesla and space. That wasn't happening. So at best, the kind of post Series A, and I raised a pretty traditional venture Series A. There wasn't really, if we were going to raise 100, 200, 300 million, there wasn't really a market for that. There was at the very late stage if we were like, making revenues and gross margin, and then maybe the very early stage when somebody could come in and take a decent amount of equity and write like a smaller check. But like in that middle period, there was just basically no man's land. So it was either going out and raising like maybe 100, 200 million at whatever valuation, or it was like go public and raise a billion. And I think, that was the trade, right? We were early pre-revenue, we were a young business, being in the public markets and, being a grown up as fast as we could, or stay private, and at the time maybe raise like very little money. So the trade was, okay, this business needs a lot of capital, maybe a $500 million to get into market. Let's optimize for capital. Let's use that capital to go out and build this business out and get into market. And we basically chose to do that. And we raised a substantial amount of capital, like a little under $1 billion we closed in the end of 2021 from that process. And that's being used to fund the development and certification of the aircraft.
It's incredible. You did it once. You signed up to bang your head against the wall, and did it, fairly well compared to many people who kind of don't build a successful business. And then you signed up to do it a second time, now with Figure. Why do it again? Are you addicted to it? Is it something where you're like, oh, I've got this playbook now? Like, what is driving you to do this a second time with advanced hardware?
I think what we're doing at Figure has the potential to be maybe one of the most groundbreaking businesses I've ever seen. And I think there's a chance here to really put robots into the physical world to help with a wide variety of problems we're facing here. We have problems in the labor force, which we think we can really help. We have problems in the consumer side of things at home, caring for the elderly. We think we can really help address. We think over a longer timeline in the limit, we can help with AGI, which will be really important. So I think what's driving me here is I think one is we can ship a lot of product, our humanoid robots, into market and make a substantial impact to humanity. And two is I think this is going to be just a really incredible business. So I think I have the saying that I really want to wake up to a future that's exciting and inspiring. I feel like what's more exciting than building robots to help with the world. And I think so here at Figure, we're designing autonomous humanoid robots. Our thesis here is that almost all the physical world was built for humans. So I have this analogy. It's similar to the internet. When you go on the internet, the universal interface is a keyboard and mouse. It's how you interact with all the web. And even your phone, your thumbs are basically like little keyboards. So here in the physical world, that equivalent is the human form. So the whole world was built for the human form to interact with, whether it's like the shelves in a warehouse that are 5 feet high, or the door I'm going to leave here, or the tools I'm going to grab and go use something with. Like everything was made for the human body. It's like we have like a human operating system in the physical world. So the play here is if you can build a robot that can do what a human can, you can basically solve like millions of problems in the world. You can do all the jobs that are dangerous and monotonous and boring that humans don't want to do. And we think here that that's possible, and it could be one of the more important businesses ever built. So I just feel lucky to be here with probably the best humanoid robotics team ever built. We're about 50 people now. We just brought up our full-scale humanoid earlier this year, and we just did first steps of that humanoid last month, which from our indication, so we basically did first steps from under 1 year from when we started with the humanoid robot, which, from what I know publicly is probably the fastest humanoid project ever built. And so I think we're making substantial progress here. And I think over the next few years, we really hope to introduce this product into market and to show it's actually feasible and really working. I think we get a lot of heat for feeling like this is maybe too far out there, or maybe like 10 or 20 years into the future that this will be possible. But we really believe over the next year or two, we can really demonstrate this into real markets. And I think that's somewhat contrarian right now in this space.
So I want to dissect kind of the anatomy of an ambitious bet, right? When you decide that, okay, this is the project that I want to go work on, what was that process like? Did you sit down and you're just like, what's the biggest market in the world? It's humans. Or did you do something else? Like, what is the process to go from, I've had my successful companies, now I want to go work on a new problem. How do I decide where to invest my time, energy, and mental focus?
Yeah, so I basically go through a whole playbook exercise for this. It's not a very quick one. It's a very exhaustive like research or database process I run through. But at the very highest point, I really want to try to make as much impact as I can. And that's generally working on frontier technology areas. I think technology is one of the biggest lever arms to make as much impact as possible in the world. And so within the kind of the technology umbrella, I'm looking for areas that I can move the needle and make as big of an impact as I can. And so I think for me, it's impact driven. What do I want to like spend my time on personally outside of that? Am I excited or inspired to be working on this X or Y project? It needs to be tractable in the sense that like this can be doable and yeah, the business can actually really work and we can actually ship products. It can't be too far out there where we spend 10 years and just don't do anything. So I think, can we raise enough capital? Can you hire the team? What is the area of research and, what is the area of maturity of this industry and different subcomponents? Yeah, so that process takes a lot of time. It's relatively exhaustive, and I want to really understand that whatever I work on is something I can actually really be successful at. I think the last 10 years for me have been like dominated by this fear of spending like 10 or 15 years of my life doing something and just not working. Like I've had, like when I started Vettery, we were in the NYU incubator. And there was like a little over 50 companies at the time. I think me and two other companies made money. Like we're successful. That's it. So maybe like that's a 6% or so hit rate. So 94% of folks just didn't make it. And they were all like highly ambitious, really smart, hardworking folks with good ideas overall. So this is a space where you need to also survive and build a business. And so when I looked at Figure, I looked at, okay, I think this could probably be one of the more important businesses potentially built by generation. The talent is pretty scarce. There was like a very small talent pool that really understood like legged robotics or humanoid robotics. It was much smaller than what I even saw at Archer, much smaller than what you would think when you look at like traditional like autonomous vehicles or electric vehicles. I had the personal balance sheet to self-fund. So like from the capital perspective, I would say a little bit different equation there, given like, the maturity of my career. And the technology side in terms of like advanced areas of locomotion, batteries and motors, the autonomy and AI systems for semantic behaviors and perception. Like I really did a lot of research understanding what the state of the art there was. And I felt very convinced that this was the right decade to make this happen. And it just needed like this full court press push. Like we had to basically build like a greatest team of all time. We would need to work really hard. We need to be really thoughtful about what we spend our time on to make sure we make actual progress because this hardware space is so damn tricky. And so we really don't have enough time to spend a year and just kind of like going in the wrong direction. It's okay if we're like heading north and we need to like pivot a little bit, it's like northeast or northwest, but we really can't be heading south for too long or it's going to be disaster. We won't make it. We'll go bankrupt. And so, yeah, I basically spend a lot of my time making sure we're going in the right direction. What is the state of product and engineering, which axiomatically for me is the most important thing. Like if you have a really good product, it's easier to raise capital, find the right partners, hire the team, ship products, have like a sticky product, like increase margins over time. Like axiomatically everything sits with the product. So I felt like we could build a really groundbreaking product here. And then on the back of all of this, we're like the economy is seeing like substantial declines in like the labor population. We just don't have anybody that wants to do these jobs anymore. So the conventional wisdom is like we'll walk in and we'll take people's jobs in humanoids robotics, and it's just false. We're walking into warehouses or manufacturing facilities. They're seeing like 100 to 200% annual turnover. There's nobody that wants to do these jobs anymore. there's like, I think there's like 11 million jobs unfilled in the US. So we want to walk in and fill that void, which we think is a really fundamentally important void to fill in the US and also worldwide. Yeah. So like I think, for that reason, I think this could work, on the back of all that work. And, I think I feel more convicted every day I spend inside the business here and inside the product that we'll have a real run at this to see, like, to try to make this happen.
When you think about how big this could be, right? You start talking about these autonomous humanoid robots. That seems like it's either the craziest idea in the world, and if it works, it could be unlimited trillions of dollars of value created, or that sounds like the most insane, stupid idea in the world, and it ends up being, this whole exercise and like everyone loses all their money. Talk to me about the upside, the optimistic view of this, right? It works. How big can it be? Or do we not even understand that yet?
I think there's like a couple, like there's like near term success and there's like obviously the long term success. I think at a very high level from a macro perspective, we're sitting in the largest economy on the planet. So the economy for physical labor is half of GDP. So half of the world's money pays for humans to do work. We have a flatlining labor population, meaning the people that we're paying to do the work is flatlining and starting to decrease globally. And that's a demographic problem. We have the baby boomers have started to retire. We haven't had as many kids. It's leaving this like the middle area of the economy, and basically in shortfall. And so we have the ability to come in and basically be a generalizable substitute for human labor, meaning we can put robots in to do the things that there's not enough humans today to do. And from the TAM perspective, it's like largest in the world. It dwarfs the transportation market, like globally. I think transportation market's big. It's probably like an order of magnitude bigger than transportation. We have this like on the supply of people, that's basically like starting to flatline and go down. So if we want growth, we need some sort of automation, and we feel like humanoids can be a great, basically product for that. And so in the near term, call it over the next 5 to 7 years, we feel we need to demonstrate that this is actually tractable and actually works, meaning we put humanoids into real labor applications and it's actually doing work that's useful. And I think that's a huge hill to climb. We're trying to climb that hill right now. I think if we're able to do that, comparatively, if you look like self-driving cars, this is certainly a bigger market, I feel. And I think it's going to be easier in the sense that like the safety for self-driving cars is a huge dependency in the roadmap for deploying robo taxis at scale. And a lot of that stuff is pre-revenue. I mean, Waymo and Cruise are $30 billion companies. So I think there's a optimistic view I have that if we're able to put humanoids into real labor areas with real big clients, actually getting paid for that and doing that over the next like 2 to 4 years, I think there's no reason this business can't be worth more than Cruise in the next like 5 years. And then I think long term, it's a matter of like being able to really scale this out with a real fleet of robots at really high reliability and high safety. And there's a ton of challenges there. We have to manufacture really high volumes, and there's a very steep learning curve for that. We have to have like robot reliability extremely high, which is hard. Like think about a million robots all over the world, and they need to be working almost all the day without any human intervention. We can't really have robots like stopping or dropping things and not knowing what to do next. Like it's impossible to have a human interface to a million robots and going in and fixing them one by one, or teleoperating in and saying, hey, robot, do this. Like we have to have the robots work autonomously across the whole mission. But I feel, if we're able to, the first hill we need to climb is like, we need to have robots into real applications doing real work that's useful. And I think we're working on that right now. We want to try to demonstrate that over the next year in our lab. And then within the next like kind of 24 months or 36 months, we would like to have early proof of concept of our humanoids in real companies doing actual work. I think long term, there should be an ability to build perhaps the world's largest business here. I think it's just the math behind how large the market is. And I'm not saying that that'll be figure, but I think the humanoid space will give like rise like some of the biggest businesses on the planet.
As you start going down this path, I immediately think, okay, who else is doing this, right? And I think most people will see Tesla and some of what they've discussed and some of the mocks and things like that they've put forward. Do you see them as competition? Do you see them as, no, actually, we need as many people seeing the opportunity as possible and kind of all boats rise together? Are there other companies maybe that you spend more time thinking about than Tesla? Talk to me about, maybe the market so far and how you think it develops over the coming years.
Yeah, this looks a lot like pretty similar to what I just went through at Archer. I think there's been no successful commercialized humanoid robotics um, company in history. So in terms of like who's actually has humanoids in market generating revenues, there's zero globally. So we kind of view like that's like the minimally viable level that we need to get to show that this could be a real company. So as of right now, there's nobody on the planet that's been able to do that. Um, I think we like at least figure because I can speak for ourselves. I don't, can't really speak for Tesla and these other groups. I think figure over the next like 24 to 36 months, our goal is to try to show that that's really possible. And I think it's going to be very hard for a lot of groups to get there, given how very little people on the planet know how to do this. It'll take a decent amount of capital, it'll take a decent amount of time. The technology is just extremely hard. So it's not like it's like, okay, just go get these things and put it all together and make it work. It's just not like that. We had to basically build from scratch almost all the software, all the powertrain, all the autonomy, like all that stuff and the controls, like all this stuff was designed in-house from scratch. And it's just really difficult to do it. So yeah, there is Tesla on the market. There's a few other groups that are kind of doing this from more of like a startup perspective, but I would say on the whole, there's probably very little competition globally. I hope more than one group kind of figures this out. It's probably not a winner take all market. I would say it's probably winners take most, similar to autonomous vehicles. The space is just too big for one company to win. But I also think it's not like 30 companies are going to go figure this out. I think it's just too hard. And I think there's a real first mover advantage for a company getting to market, basically using the perception systems and sensors to build an AI data engine, which then in turn is going to train the robot on how to do new things. So the initial robots will be in market as a fleet, gathering data, training the neural nets on how to train the robot to do new applications that will then in turn allow the robot to do two new things it was never, taught to do initially. And so that's going to be a really important flywheel that we need to start from day one that we're starting on right now that will be really hard to compete with if you have a bunch of, if you have a few companies in market that are generating that data and you're a new up and comer 5 years later, it'll be very difficult to compete in my mind.
One of the questions I was going to have for you is, are you a hardware company or a software company at the end of the day, right? It's kind of Tesla. Is it a car company? Is it a software company? What is it? Maybe the labels or the characterization of the business doesn't actually matter at the end of the day. Like the market's just going to determine the winner. But how do you think about where those moats are? Is it in the data, or do you think that there's just really hard technical problems with the hardware that if you figure it out, other people will struggle to do it?
So in the limit, I think Figure is going to be an AI business long term. So we incorporated Figure AI Inc. It's Figure.ai. In the limit, the autonomy and AI will ultimately drive like long-term success characteristics of the business. And like on that way, there's a bunch of other things we have to get right and not take for granted. And the hardware's got to be great. And inside the hardware umbrella, there's a lot of pieces here. There's, actuators, which can be broken down into like the motor and the sensors and transmission. So there's a lot of stuff there. There's the rotor, stator, transmission, sensors, enclosure, controls. There's a lot in that little umbrella there. The battery areas, the joints, the kinematics. We have to get the control software right. We have to get the middleware operating system right. We have to get all the electronics right. So at this point, we're building all of our electronics from scratch. So there's a lot of things we need to do right. And I think even in this near-term window, I think in the robotic space, I think a lot of folks a lot of companies in the last couple of decades have really taken for granted how important it is to design really great hardware. I think folks, feel like, okay, it's we'll just buy some motors and some robots off the shelf and just design great software. To build a great robot, the hardware needs to be really great. And the hardware is just extremely tough. There's a lot of degrees of freedom. There's a lot of parts, a lot of failure conditions. So we try to build hardware really well here. So we have a really large hardware team. The team is just absolutely fantastic. We're working now through our second generation robot, which will be done within the next like several months. And I think we're making some of the best improvements in humanoid robotics on the hardware side I've ever seen. But yeah, I think getting back to your position, I think in the limit we become a software AI business, and there's just a substantial amount of work that we can do in here to make the humanoid useful at scale.
So one of the things everyone is either worried about or excited about when it comes to AI is AGI. And if you have a humanoid robot who stands, let's say, on a kind of manufacturing line, and you say, pick up the box, put it on the conveyor belt, pick up the box, put it on the conveyor belt. People are like, oh, that's amazing. I can see why that's valuable. The second that you say to the humanoid robot, hey, go into this building and figure out how to make me money, people get a little uneasy. When there's even grander things that aren't just like, hey, go to work essentially and figure it out, people get even more uneasy. How do you all think about the pros and cons? Is AGI inevitable in these humanoid robots? And like, what are some of the things maybe that you haven't figured out, but you're thinking about today and need to figure out before we get there?
There's really this debate that's happening right now, like as it relates to AGI, on whether there's enough data online to basically get to AGI. Is there enough, say high quality words that can be trained in a large language model to get the real AGI? I think there's roughly anywhere from 7 to 9 trillion high quality words on the internet. Maybe we've ingested close to a trillion at this point. And, is that enough to really have the semantic understanding of the world and to get the AGI? And if it is, it's definitely the cleanest and best path towards AGI, or the fastest path. If we happen to find, and I'm a bit skeptical here that we're able to do it, but if we're able to not get there through language, then I think the highest predictable path to AGI is going to be through humanoid robots, and so both on like the vision language side. And so
Explain that
it's
a
a
little bit more, Brett. In terms of, I think when you say that, a lot of people will say, "Wait a minute, I would think that that would be kind of the last frontier." Why do you think that is really the path?
it's probably the last frontier if we're not able to get there through language. Meaning, if large language models are not able to semantically really understand the world the way maybe humans might, because we have a physical interaction and embodiment, humanoid robots are probably this like last frontier to get to AGI. It's going to take much longer than like through language, but it's a much surer path to AGI. Like if there is a path to AGI that can't be done through language, it's definitely going to be done through humanoid robots. It's just going to take like an order of magnitude or longer timeline to get there. And so I think in the limit, we should be able to here to make pretty substantial progress on that front. It's just going to be much harder because we need a robot embodied AI in market, collecting data in the real world and policy information, and doing that training on the physical embodiment, which is much harder to do than just scraping the web and doing next word prediction.
Talk a little bit about the war for talent. Like, as you're talking about this, right? There's obviously language. There's all these kind of different things that you're throwing out there. And all I'm thinking in my head is, man, those are some of the hardest people to recruit, to get them to stay, compensate them, do all the things that we know go into this war of talent. And it's just a supply demand imbalance. So how are you all thinking about that? And how are you guys seeing where maybe you have an advantage in terms of getting people to come work with you?
Yeah. So I think about 3 or 4 years ago when I was scaling up Archer, the war for talent on that side of things in electric aircraft was really on the powertrain side, like batteries and motors. And that was a time when all the electric vehicles were scaling up. Electrification in general was like, all the car OEMs were pivoting to electric vehicles. It was just like some of the hardest talent I've ever recruited. And then, fast forward now 3 or 4 years here at Figure, the talent for AI is like even more extreme. So we're at, today really competing head on against OpenAI, Tesla, Cruise, these Bay Area AI companies. We're really trying to hire the same exact talent. So in a lot of ways that is being recruited here. And it's arguably some of the hardest talent we're trying to hire here at Figure. Luckily, we've had a large amount of success the last 12 months building out our AI and autonomy team, which today is like, I think we're like a little under 10 or so folks. And the team is incredible. I mean, we have folks from Cruise and Google DeepMind that have worked on like very sophisticated models and policies, and the whole team is trying to solve these problems. Basically, we're basically using learned policies in that group on the humanoid that will ultimately be, yeah, in market, trying to get smarter every single day. It's I would say really fierce. I mean, we're when we lose people, we're losing people because they're getting paid several $100 million in cash, seven figures in stock options or stock RSUs. I would say it's one of the more competitive areas I've ever seen in my career for talent. Luckily, we have this really interesting area of embodied AI that folks can come into. I would say it's a relatively I think it's a relatively important area, and it's a relatively hard area. So I think it really attracts a certain type of person that wants to come in here and basically run embodied AI or AI that would run on actual hardware.
When you see the progress that you all are making, what is the inflection points that are yet to come that you think that you guys can make before you've got to get into the public markets or like, kind of get into the billions of dollars raised, right? Are there certain things that you all are driving towards? You said you just took the first steps. What's kind of the next couple of things that you all look as those milestones?
Yeah, I think there's like two things that are on the roadmap right now that we're working through. I think the first is, which is arguably the most important, is we need to show a humanoid works really well in a useful scenario in our lab. So in our lab here, we have a full testing area. It's relatively large. It has a full like warehouse and fulfillment studio built into there. And that like basically mirrors what we're seeing in market at our clients. So we want like really high transferability. We want the robot to do well in our warehouse or fulfillment area here in our lab. And then we want the robot then to go into our clients. And then we want the robot to do extremely well there. So that arguably the most important hill that we're climbing now in the milestone is like you walking in one day and watching the humanoids do useful work at human speeds like all day long. They're going out and doing the work. They're self-charging, coming back in. They're doing the work again, and they're just doing that 24/7. And we're minimizing the amount of human interventions, meaning like the reliability is really high. The humanoid's like not messing up throughout the day. It's safe. So meaning like if humans are walking around, there's like there's a dynamic sense of the robot of like not slowing down as it approaches humans. Just overall like basically adhering to the system safety engineering requirements that we have for the robot. So I think that's like the most important near term goal that we have. And then in parallel, we're starting to have very significant conversations with our first potential clients and what that would look like. We're spending, I would say, 2 to 5 times a month. We're on site at a facility somewhere in the US, whether it's a car OEM or a large like retail or warehousing client, and we're there for the day, just absorbing everything end to end and how it all works, and spending time understanding their pain points, what requirements they need, what performance they need, what does like their hiring pains look like, and labor attrition and things like that. And I think those two go hand in hand, right? Like it's like we want to understand what the clients really need, and we want to really demonstrate that in a really useful environment here in our lab and make it like as real as possible. And then to the extent that works, we want to put a limited quantity amount of humanoids into those first clients as a proof of concept, meaning there could be 5 or 10 humanoids at X client, end of 2024, doing useful work. And to the extent that's working well, we would basically scale up into that application. And then we would use our AI data engine to basically teach the robot how to do new things along the way.
So as you're talking about kind of these different things that you guys have to do, how much capital are you going to need? Right? Like is this a capital intensive thing where it's the talent? Is it something where as you mass produce the actual humanoids, can you get like lending facilities against the hardware? Like how do you think about, being able to efficiently use capital to be able to build this business? And are you going to have to just do it with all equity and go raise billions and billions of dollars, when you're at scale? Or are there other things that maybe you guys are thinking about in terms of how to finance, building out what essentially is a fleet of, these humanoids?
So I think, so my view is that this business, we have like probably the minimum requirements we need a capital to get into market at low volumes. And then we have this scenario of like, if it works, how much capital is going to need. Starting with like, if this works, how much capital is going to need. So to the extent humanoid robotics are useful, we have them into clients, it's working really well, we can manage the fleet well, everything's going well. You'll probably be able to manufacture more humanoids per year than cars. So we have like roughly 100 million cars produced in the world every year. I think there's an ability probably to put close to 10 billion humanoids on the planet the next like 2 to 4 decades. So you would have like a huge ability to manufacture a ton of capacity. That business will need substantial capital. You'll need capital like a new electric vehicle startup, billions, tens of billions, that sort of thing. But that's basically in like high growth scale. You'd really understand the economics well. Humanoids would be scaling into market. That'd be a very different type of environment that we're in today. And then there's the question of like, okay, we're like reversing back to where we're at now is like, what is really needed to get in the market? The good news for like our business is we don't have to have like huge manufacturing scale to get cost to a certain point to where it's economical for the consumer. So like electric vehicles basically have a already baseline. Like there's already like this existing competition. There's already high volume like car OEMs that are manufacturing really high scale. Like you have to compete against that. If you're Rivian or Tesla or these new groups, like there's a certain, you just can't like, it can't like be any price. There's already a baseline of what consumers will be willing to pay and what they can afford to pay that you really need to hit. And you need like really decent scale to get costs down. And so that's why you're seeing substantial amount of capital flowing in here. In the robotic space, we could theoretically deploy 10,000 robots in a market, be unit economic positive or cash flow positive and stop growing. And so I think here we need, into market at low volumes, probably low hundreds of millions of dollars from here. We just announced last month a $70 million Series A. We had just a great group of investors in. I also participated in the round. And that basically gives us enough capital for the next several years. So we're really at this point heads down now, just trying to get the robot to do useful stuff. Like, let's use the capital to prove out a humanoid can be commercially viable. And if we can do that, then it basically, I would say, unlocks. If we're able to demonstrate the humanoid can actually be useful in a commercial way, I would say it'll unlock this area of almost unlimited capital for the space. And the space is just so large and nobody's been able to get to this point. And I think we're really trying to get to that point over the next several years.
Talk about Boston Dynamics and like they're, people I think have seen the videos where they're have human-esque things kind of doing flips or, jumping on top of stairs or whatever. The dogs, maybe whether it's Boston Dynamics or others, those seem to get, tons of virality. How much of this game is like what there seems to be much more the hardware and like kind of driving it versus you all have a very specific, kind of idea of like, we are building a humanoid robot. And so we're making design decisions. We are making technology decisions specifically for one use case. Maybe that's just my like, kind of stupid external view as to they seem more like, let's do science and technology research and like, we'll apply to a bunch of things. Whereas you all have this like laser focus. Is that an advantage or maybe I'm even seeing that wrong from the outside?
I think your assessment is correct. I think Boston Dynamics is really, the heritage of Boston Dynamics has really been in research and development. And I think their humanoid program today, Atlas, which is like a hydraulic humanoid, is in a research and development phase. And but I think Boston Dynamics has done such an incredible job last like couple decades for robotic space. I just grew up watching their videos, and they've just done an incredible amount of great engineering work. Mark Rabert, the founder, was actually in our lab last week. We had him touring around, showing him the robot. He's such a great guy, and we have a decent amount of folks in Boston Dynamics here now at Figure that he knows really well. But yeah, I think your assessment's correct. Boston Dynamics has really been focused on research and development. So I think their goals of what they really want to accomplish are very different at a high level than what we want to do. I think they really and this is just me speculating from watching from afar, but I think they really want to push the technologies to places that are almost as good or better than what humans can do in terms of like, agility and locomotion and speeds and these different things. And that's kind of like the inverse of what we want to do. It's like we're at the complete opposite end. We want to do nothing better than what like a non-expert human can do. So we look at like the distribution of what every human can do in terms of like what they do every single day. We basically want to do the most amount under the curve of what a non-expert human can. So that means we don't want to do box jumps and backflips and super fast speeds. It means we want to just do the blocking, tackling work that a most normal human can in the world. And I would say that's pushed, like at the very high levels, probably pushed architecture decisions and the technology in a very different place. Our robot is fully electric or electromechanical. We don't have the ability to do like 100-pound deadlifts and other things like that, nor do we want to. So I would say, at a whole, you're probably right. And but Boston Dynamics is just an incredible organization. They probably have some of the best roboticists on the planet that are there today. And I think we're super fortunate to have them in the industry, pushing us to where we're at today and pushing us forward.
I got two more questions for you, and then I'll let you go. The first is the military has a robot called the Talon robot. And what always surprised me, it's something that's used to kind of go down the road and look for IEDs. And this is a thing that is built for the most robust, environments in the world, could literally get shot at, etc. But when I see people use this thing, it can also take an arm, and it's got kind of like a pincher type device on it. And it could, with a skilled operator, pick up an M&M without crushing it. And so this kind of, difference between like, you got to be robust enough to end up surviving and thriving in a war zone, but also have the minute ability to pick up things with a delicacy to not crush them. Always struck me as this like very weird, illuminating challenge in robotics. What you all are doing seems almost even, more complicated, right? You're talking about being able to walk up without slowing down. You're talking about being able to pick up a certain, weight worth of things, but also probably have to do certain things where you can't crush or break or, kind of violate. How do you balance that? And how much of it is just driven off of the understanding of what a human can do versus you all are looking at this as like, we're designing a machine. We take some inspiration from humans, but it is a fundamentally different thing in terms of, the capabilities of the machine.
Yeah, so I think you're hitting on like a really important point, which is to do everything a human can is extremely complex. Like if you look at like the easiest stuff a human can do, just moving boxes, and the more dexterous stuff, more fine-tuned stuff you talked about, like putting a humanoid say in a home and cookie dinner. The engineering challenges there from start to finish are substantial. And in some way, I equate like this hardness scale similar to self-driving, where you have self-driving cars that, if you want to build a self-driving car that drives on the highway, a decent safety standards and reliability versus like, say, a self-driving car, say in the city of San Francisco, like the difficulty scale is probably like, I don't know, maybe 1 or 2 orders of magnitude difference. Meaning you can get to market faster if you can just design like a drive on the highway. So my Tesla drives fine on the highway. But then driving to the city just creates a lot of variability, less structured environment. It's just like very, very difficult from a safety perspective to do that reliably. I kind of think the same thing for humanoids. We have this like scale of like easier stuff, like moving boxes and bins and fulfillment that might be like, say, like highway driving. And then there's like the more difficult stuff, which is like put a humanoid in a home to cook you dinner in an unstructured environment. Every home's different. You're going to basically have different types of language prompts to those humans, like from humans to the robots. So our roadmap is designed so we basically chew that off in some way, like almost serially, where we can enter market, use the data coming off the robot to train the neural nets to basically get us from point A to point B, C, D, E, and over time. So I think that's the way that this industry will unfold. We'll see humanoids in factories and warehouses and manufacturing. And then over time, they'll be in more dexterous areas of retail and other environments. And then, the last chapters in the book are like space travel, cooking dinner in your home, caring for the elderly, those type of things. Once the cost is down, safety's up, things like that. So I think, I think it's extremely difficult to answer your questions directly, and we're starting with more tractable areas that we think are have huge labor problems that we can actually be successful. And these spaces are also enormous. We could ship tens of millions of robots into like warehouses, for instance.
Yeah, it's fascinating to kind of think about all of the nuances here. My last question for you is kind of a fun one, but a little personal. What's your greatest fear in doing all of this? Like people see a founder who has continued to level up their game, go for something even more ambitious, go for something even bigger. What are the things that keep you awake at night, or what are the things that you're kind of most fearful of?
I think the thing that bothers me the most as an entrepreneur is spending a large amount of my time on a problem or business that just doesn't work. I think that's arguably the least helpful I can be to the world is I work on a problem for 10 years, make some small amount of progress, but not material, and it just doesn't work. And I think it's my biggest fear as an entrepreneur. And I think it's probably every entrepreneur's biggest fear. And I've seen it just happen so many times across just so many industries and so many friends. So yeah, and that can basically be like you can kind of control that destiny. You can control the speed of decision making, the speed of progress you're making, who you hire, uh, how well those folks perform as a culture and as a direction as a CEO. Like those are really things I feel like are balls in our court to really do. I think at least for what I view it here, a Figure and even Archer, it's like this is all possible. It's ours to lose. Like we just got to go out and get it done. And if we're not able to get it done, it'd be pretty upsetting because I feel like we have all the ingredients now on the table to make that happen. Like there should be no reason why I think there should be no reason why we hit this wall it's just not possible to do.
I'm cheering for you, man. I think this is super cool.
Thanks.
And I think that there's a lot of people who, when they hear what you guys are working on, yeah, there's kind of like a why would they do that? And then once they understand the viewpoint, the opportunity, and how impactful this could be, it's hard to cheer against somebody who's taking the time and energy to go build something like this. So you've got a fan here, and I think a lot of people who watch and listen to this will also be fans. Where can we send people to find either you online or if they want to learn more about what you guys are doing at Figure?
Yeah, so I would say definitely go to figure.ai. It's our website for the Figure company. I think we have basically a long-term outlook that we wrote called the master plan. We have a culture document. We try to detail it as much as possible. Please follow us on Twitter. We'll be posting a lot of interesting updates this year and next. So we're going to try to be a lot more. We're going to try to be extremely open in terms of like building in public. And I think like this is such an interesting space. We'd really like to set the business up so people are cheering for us. We don't want people rooting against us. So we really want the world just hoping that we can make this really work. So yeah, I would say follow Figure online on Twitter and LinkedIn. And I'm also personally on Twitter. I try to address every week what's going on at Figure. And I'm personally trying to build in public more. And I think it's been really useful so far. I mean, we've had so much inbound demand for talent and capital and partners and stuff. I think we've had almost 20 big corporates. Like I would say probably we've had like almost 20 Fortune 500 companies come inbound over the last like 6 months, which has been great. Same with investors, same with, folks trying to apply. So yeah, thanks. Thanks for having me on. And yeah, hopefully have some more to share later in the year.
Autonomous humanoid robots for the win, my friend. Thank you so much for taking the time to do this, and we'll definitely do it again in the future.
Yeah, thanks for having me.